Okay, Mr. Cooper back. I'm going to talk to you a little bit about a couple of different things in Module 8 on solution concentration and dilution. So I'm going to do 4 problems. So I'm going to go fairly quickly showing you how to solve 4 problems. And you can obviously stop the video and go back and look at it and slow it down. Okay, so I want to help you out with the math stuff. So we're back into problem solving, which means numbers. So have your calculators ready. So to start out, we're going to talk about solutions, okay? Okay, so there are 2 parts of a solution. Number 1 is the solvent. Number 2 is the solute. Okay? The solvent is what does the dissolving, and the solute is the stuff that you're dissolving. Okay? So like in a saltwater solution, the solvent would be water, and the solute would be NaCl. Okay, so if I want to make a saltwater solution, I would have to dissolve sodium chloride in water. Now, how concentrated the solution is means how much salt is present per amount of water. The unit that we're going to use in chemistry for concentration is something called molarity. Okay, so concentration is how much solute per solvent. Okay? That's what the general term concentration means. So if I have a really concentrated Kool-Aid solution, it's really dark. I got a lot of Kool-Aid and probably sugar dissolved in there. If I have a very dilute solution, it has a very low concentration, not very much color, not very much sugar. So the unit that we're going to use for concentration is something called molarity. The symbol we give it is M, okay? And we're going to define that as the moles of the solute divided by the liters of solution. Okay? So the molarity is M, and that is defined as the moles of solute divided by the liters of solution. So let's do an example on how we would calculate that. Okay? So again, you can stop this and rewind. I'm going to put that equation up here. The molarity is the moles divided by the liters. So you just have to remember, when I say moles, I mean moles of solute, and when I say liters, I mean liters of solution, not the liters of water. That's important. Okay, it's the liters of solution, not the liters of water. Okay, so let's say that I have, let's see, my example is 9.96 grams of acetic acid in 200 milliliters of solution. Okay, most of that is water, but remember our definition is moles of solute per liters of solution. So the way I'm going to make this is I would take some of this acetic acid and I would add it to a beaker, and I would add water up to the 200 milliliter mark, because that acetic acid is going to take up some space. So the 200 milliliters is the total solution. So the question is, what is that molarity? So that's our first problem right here. If I have 9.96 grams of acetic acid in 200 milliliters of solution, what's the molarity? So the molarity, again, is defined as the moles divided by the liters. Okay? And how many moles do I have? Well, the problem is I've got grams, so I have 9.96 grams of HC2H3O2. I got to turn that to moles. So 1 mole of acetic acid is about 60 grams. Okay, and then if you're doing your calculations, you'll find that it's about 0.166, 0.166 moles of acetic acid. Okay, so I'm going to put that there, 0.0166 moles. And then I have to make sure I put these 200 milliliters in liters. So how do I go from milliliters to liters? Remember, I got to divide by 1,000, so that would be 0.2 liters. So if I take 0.166 divided by 0.2, I should get about 0.830. Okay, so what I've created by putting in 9.96 grams of acetic acid in the solution is what we would say a 0.830 molar solution of acetic acid. Okay, so that's just using that molarity equation. Okay, let's do another one, but a little bit differently. Okay, so the second problem. How do I make 1 liter of a 2 molar solution of magnesium chloride? How would I do that? Well, we're going to start out with the same equation. How would I make it? Well, I already know that I want 1 liter, and I already know I want a 2 molar solution. So let's just plug those numbers in. So 1.0 molar. I don't know the moles, but I do know the liters. Let's see, actually I got this wrong. This is a 2 molar solution. Okay, and I have 1.0 liters. So how do I solve for the number of moles of magnesium chloride? Well, you got to cross multiply, right? So what we're going to find here is the moles is equal to the liters times the molarity, if I rearrange that equation, right? If I solve for moles, I multiply both sides by liters, and that's how I get this equation, okay? So I know that I have 1.0 liters that I want. I want a 2.0 molar solution. So how many moles of magnesium chloride do I need? Well, 2 times 1 is simply 2, so 2.0 moles. And that's a magnesium chloride, right? So I just need to put 2 moles of magnesium chloride into a container and add a liter of water, and then I've got a 2 molar solution. Well, I usually measure things in grams, not moles, so I'm going to have to change this 2.0 moles of magnesium chloride to grams. Okay, so the molar mass of magnesium chloride, let's see, 95.2, so 95.2 grams is 1 mole of magnesium chloride. Moles of magnesium chloride cancel, so 2 times 95.2 looks like about 190.4 grams of magnesium chloride. So remember, the question was, how do I make this solution? Well, what I'd have to do is I would have to take a container and I'd measure out 190.4 grams of magnesium chloride. I'd put it in that container, and then I'd add water up to the 1 liter mark, mix it all up, and I've got my solution. Okay? So it's the same equation as we used in the first problem, except I just rearranged it to solve for a different variable. I could also rearrange it to solve for liters if I wanted to. So real quick, how would I solve for liters? Well, liters is going to be equal to the moles divided by the molarity, right? So you can solve that equation in 3 different ways. Either solving for molarity, solving for moles, or solving for liters. Either of those 3, any of those 3, okay? All right, next 2 problems involve something called dilution. And you guys have a good understanding, I think, of dilution. If I take some really, really strong coffee or Kool-Aid and I dilute it, what do I do to it? Well, I add water. That's what happens when I dilute something. I add water. Okay? So let's look at what happens when I dilute something. Okay, so this is important now. I'm going to derive an equation for you real quick. So when I dilute something, I'm only adding water. I'm not changing the amount of solute, right? So I can say the moles of solute before the dilution is exactly equal to the moles of solute after the dilution. Okay? If I'm just adding water, I'm not changing the amount of solute, right? Well, remember from the previous board, moles is liters times molarity. So this is the before the dilution. So I'd have to have the liters before the dilution, the molarity before the dilution would be the moles of solute before the dilution. And then the moles of solute after the dilution is also going to be liters times molarity, but I'll call that A for after the dilution. We could call this 1s and 2s, it doesn't really matter, okay? So I've got my basic equation here that I can solve problems with. So let's look at this third problem. I need 0.5 liters of 3 molar HCl. I start with 10 molar HCl. We're going to call that a stock solution because I have that back in my stock room, a more concentrated solution. And quite often I need to make a more dilute solution of things to prepare labs or demonstrations. So how do I make it from a solution that I already have? I already have a 10 molar solution of hydrochloric acid. How much of that stock solution do I need and how much water should I add? Well, all I got to do is fill in the numbers in that really simple equation. So if I need 0.5 liters, that's what I want at the end. Okay, so that's going to be the liters after. Okay, and the solution concentration I want after is 3 molar. Okay, and I'm starting out with this 10 molar stock solution, so that's my original concentration. Okay, the only thing I don't know is how much of that 10 molar stock solution I need. So I have a really simple equation to solve. I'm just going to solve for the volume or the liters before the dilution. Okay, so that's going to be 3 times 0.5, which is 1.5, divided by 10. So it looks like about 0.15, and that'll be liters of stock solution. Okay, so the first part of the question is, how much of the stock solution do I need? Well, I'm going to need to have 0.15 liters of that stock solution as a starting point. Okay, now how much do I have? How much do I need total? Well, I wanted 0.5 liters. 0.15 of that was the stock solution. So how much water should I add? Well, it's just going to be a subtraction problem. So I'm going to have 0.50 liters. That's the total amount of solution I want at the end. I'll subtract the 0.15 liters. That's the stock solution. The rest will have to be water. So what's 0.5 minus 0.15? Looks like about 0.35 liters of water added. Okay, so to make this solution, this 0.5 liters of 3 molar HCl, I'm going to start out with 0.15 liters of 10 molar hydrochloric acid, and I'm going to add 0.35 liters to that, and then I will have a total of 0.5 liters, which is what I wanted. That's an L. And the concentration will be 3 molar. Okay? So I know that's kind of fast, so you can rewind it and look at it again and listen again. All right, let's do one more example, just so you can get a good feel for that. The last example is I need 70 milliliters of a 0.55 molar sodium chloride solution, and I have available a 1.45 molar sodium chloride solution already made up. How do I make it? Okay. Well, let's go back to our original equation. Since it's a dilution, we know that the moles of solute before equals the moles of solute after. So that's how I derive this equation. This time they gave me milliliters, so let's do something that's kind of nice. I could divide this by 1,000 and turn it into milliliters. I could also divide that by 1,000 and turn it into milliliters. So if I divide an equation by the same number, I'm not changing anything with the equal sign, right? So I'm going to make this a more general equation. If I divide both sides by 1,000, then this can just be milliliters. And as it turns out, any old volume. So we're just going to use V for volume. Okay? So this is an equivalent equation. We could have used this to solve the first problem as well. So the equation that is sort of the more general equation is the volume before the dilution times the molarity before the dilution equals the volume after the dilution times the molarity after the dilution. Okay? Now I can put whatever units I want for volume as long as they're the same on both sides, and the problem will work out fine. Okay? So the goal is to make this 70 milliliters of a 0.55 molar sodium chloride solution. So where does the 70 milliliters go? Well, that's what I want at the end, so that's my volume after. So I'm going to put 70 milliliters. Note I'm just going to use milliliters because that's what they gave me. And I want a 0.55 molar solution. Okay? And what's my stock solution? What am I starting with? I'm starting with a 1.45 molar solution. So the only thing I don't know is the volume of that stock solution I need to begin with. So I just need to solve this problem. So the volume before the dilution is going to be the 70 times the 0.55 divided by 1.45. And the number that I get looks like around 27, okay? And what will the units be? Well, if I use milliliters on this side, it's got to be milliliters on that side as well. So this is going to be 27 milliliters of the stock solution. Okay, so how do I make it? Well, I'm going to take 27 milliliters of that stock solution, and what else do I need to do? Well, remember, diluting means I'm going to add water. So where's that coming from? Well, that's the stock solution. I'm going to have to add some water. How much? Well, the total is 70 that I wanted. I'm going to subtract the 27 milliliters of the stock solution, and it looks like I'm going to have 43 milliliters of water that I need to add. So to make this solution, the 70 milliliters of a 0.55 molar solution of salt water, I need to take 27 milliliters of my concentrated salt water that I have as 1.45 molar and add to it 43 milliliters of water. That would give me a total of 70 milliliters, and the concentration will be 0.55 molar. Okay? So there's 4 problems to help you with the first section or a couple sections in section 8. And the next video will have to do with acids and bases. So I hope you guys are doing well. We'll see you next time.